Hello and welcome to Water Quality. In this video I'm going to give another example of using EDTA titrant data in order to evaluate water hardness. So in this example we want to know how much EDTA would be added to determine the hardness of the solution from the previous example. And the sample volume is 50 mils and the titration concentration, so the EDTA concentration, is 0.01 molar. Okay, so first of all, we need to get the answer from the previous video. So in that video, we used the theoretical makeup of the water to calculate the water hardness. And so that was water hardness was 0.007458 equivalents per liter. And I'm using the equivalents per liter here, not the milligrams per liter as CaCO3, because we're going to use it in an equation. So the equation we're using is for hardness, and I'm going to write it a little bit different this time. So the volume of EDTA that I add in the titration times the concentration of EDTA is equal to the moles of EDTA that's added. And this is equivalent to the mass of hardness in the solution. So it's the sample volume times the concentration of hardness. So when I multiply a volume times a concentration, I get a mass, and this is just telling me how much mass of EDTA I add is equivalent to how much hardness there is. Okay, so and in this problem, I'm solving for the volume of EDTA that I'll add. And so let's see, I'm going to put the concentration of EDTA here. And we have to be pretty careful with the units in this problem. And so this is going to be 50 milliliters. It's okay that my liters and milliliters don't match up because I want my answer to be in milliliters. And then the concentration of hardness is what we found in the previous video. Okay, so I do have a problem though because my concentration of EDTA is in moles per liter, and my concentration of hardness is in equivalents per liter. So I need to adjust this, and I'm assuming that all of the hardness, this is my assumption, so I'm assuming my hardness is all divalent. It's not really assumption here, because in this problem, or in the last video, all of the hardness came from calcium and magnesium. And so those are divalent ions. Now, if you had a different problem that had some, say, triprotic ions, then you would have to make an adjustment here. We don't have to worry about that. So we have 2 equivalents per mole over here, and that will take care of it. So then I can solve for the volume of EDTA that will be added, and I get 18.5 milliliters of EDTA added. And just to clarify, this is added to a 50 ml sample, and this is what we would add in the titration to titrate that solution. So there's our answer.